Hello and welcome to all. In this lecture, we are going to discuss how to design the push-down automata or PDA for the given problem definition. So, design of PDA. Let us consider some languages given. Design of PDA for the language L is equal to A raised to n, B raised to n, where L is greater than 0. Okay. So, for this language, we want to design the PDA. So here if you consider L is equal to 3, then language will become A raised to 3, B raised to 3. Are you getting it? A raised to 3, B raised to 3 means 3A, after that 3B is there. And we want to design the PDA which will accept these kind of languages. If we are having 3A and after that 4B is there, that time that language should be rejected by the PDA. So here PDA which will consist of one tape, and here inside that tape we have placed that 3A followed by 3B, because that tape is divided into identical square and each square is called as cell, and each cell consists of some input symbols. So 3A and 3B's are there. Let M be the PDA which accept the above language, means L equal to A raised to n, B raised to n, and M which is defined with the help of total 7 tuple capital Q finite non-empty set of state which are required to design the PDA for the given language. Summation set of input alphabet, tau is the stack symbol, delta is the transition function, mapping function or next state function, Q0 is the initial state or start state, F is the set of final state, and Z0 is the initial stack symbol. Then how to design it? For this what we are going to do? For A input, whenever we are having A input, we are going to perform push operation, means we are going to push all the A inside the stack. Whenever we will get the B, whenever first B is occur, that time we are going to delete the topmost A from the stack. Next B we are going to delete the next topmost symbol of the stack. Like this we are going to delete. Once B is over, that time inside the stack it consists of only Z0. So now we have to decide whether we want to accept it by final state or whether we want to accept by using empty stack. If you want to accept by empty stack, then we have to delete that Z0 from the stack. If you want to accept it by final state, then we have to keep that Z0 as it is. We'll see its algorithm step by step. So here first one, if there is an input A is there, so A which will going to push onto top of the stack. So initially stack is like this, which will consist of only Z0. Z0 is the topmost symbol inside the stack. So once we'll get input A, so A now current state is Q0. Q0 is the current state. Current input symbol is A. Okay. Inside the stack now inside the tape first input symbol is A, and top of the stack is Z0. So Q0 is current state or initial or start state. A is the current input symbol and Z0 is topmost symbol. So as we have decided, we are going to perform a push operation. So Q0, now we will be in the Q0 state, and now we are going to perform push operation, means Z0 will be replaced with A Z0. Now Z0 is replaced with A Z0 and top of the stack is incremented by 1. Now top of the stack consists of A. Now after this, we are going to point to the next A. Okay, first A is over. For next input A, suppose Q0 is the current state. Okay, we have not changed the operation, we are going to keep the same operation, that Q0. After reading A, so current input symbol is A. Okay, and top of the stack is also consist of A. Okay, because A is previously top of the stack is like this. Okay, because in the stack only single A is there. Okay, top of the stack is A. Now what we are going to do? We are going to replace that A, means for all A we are going to perform push operation. That's why we are going to replace that single A with double A. So it will be A. Now top of the stack will be like this. Okay. So after performing push operation for second A, now we are going to read head will be incremented by 1. So it will be pointing towards the third A. So Q0 after reading third A, next input symbol is A. Top of the stack is also same, it is A. So again we are going to continue with same operation, push operation. So now this A, first A, topmost A will be replaced with A. So now it will consist of 3A. Okay. Okay. Now after for all A, now we are having input symbol as a B. Now we are pointing towards input symbol as a B, and top stack will have 3A and Z0, where top of the stack is pointing towards A. Now whenever we are having input B, top of the stack is A, we are going to perform the pop operation. Means now we are changing the state, because we have changed the operation. So we need to change the state. So we have changed the state. from Q0 to Q1, and we are going to replace topmost symbol A with epsilon. So here one A is deleted. Now inside the stack two A's are there and Z0 is there. Where top of the stack previously it is pointing to third A, now it is pointing to second A because top of the stack is decremented by 1. Now for next input means next B is there. For next B, A is popped from the stack. So Q1, now current state is changed. It is Q1. Top of current input alphabet is second B and top of the stack is again A. So now again we will going to continue with same operation. Whenever B input is there, we will going to delete the topmost symbol. So now A is deleted. So second A is deleted. Now top of the stack is decremented by 1. So inside the stack only AZ0 is left and top of the stack is pointing to first A. Again we will going to continue with same operation as input is also third B is there. 2B is already left. So third B is there. So we will going to continue with same operation, same state. Q1 after receiving B, top of the stack is again A is there. Okay, so we will going to delete that A from top of the stack, and top of the stack now stack will become only consist of Z0 and top of the stack is pointing to the Z0 after all these operation. Okay, now if all inputs are over, means 3A's and 3B's are over, so string will become empty. So now current state is Q1, input alphabet is epsilon and Z0 is the topmost symbol of the stack. If you want to accept through empty stack, then we have to delete this topmost symbol of the stack. Now as symbol is changed, okay, symbol is changed, we are going to change the state. So state will become Q2 and we are deleting that Z0 from the stack as we are accepting through empty stack. So Z0 will be deleted, stack will become empty. Okay, so that's why we have replaced Z0 with epsilon. So delete Z0 from the top of the stack and stack becomes empty. Here it is accepted through empty stack. Now there may be the case we don't want to accept through empty stack, we want to accept through final state, means we want to keep Z0 as it is. So we want to keep Z0 as it is means we want to perform no operation. So if all inputs are over, means 5 or 5, here we can say that 5 or 5. So if all inputs are over, means string will become empty, 3 B's are over. So Q1 is the current state, epsilon is the current input symbol and topmost symbol of the stack is Z0 if you are not deleted. Then we have as symbols are changed, operation is changed. No operation is also one of the operation. So we are in Q2 state and we are keeping Z0 as it is. So keep Z0 as it is, and here it indicates that it is accepted through final state. So design of PDA. So we have considered all those transitions Q0 A Z0, Q A Z0 for first A. For all remaining A, for second A. Here top of the stack is, it will be A actually. Okay, Q0 A comma A, it will be A. After that Q0 B A, it will be Q1 comma epsilon. For Q1 B A, it will be Q comma epsilon, and acceptance through empty stack, then Q2 comma epsilon. And with the help of this, we will going to draw the transition diagram. So see here, Q0 is the initial state. Okay, Q0 after accepting A as input, where we are in the same state. So after accepting A input, we are in the same state. At that time, after accepting A, we are in same state. At that time, top of the stack is Z0 and we are getting the output as a AZ0. So it will be AZ0. This is first instruction transition diagrams. For second, Q0 after accepting A, top of the stack is A. So after accepting A, I will write here. Okay, after accepting A, top of the stack is also A and we are getting the output as a. Now next one, Q0 after accepting B, we are in Q1. So after accepting B input, we are in Q1 state. Okay, at that time top of the stack is A and we are getting output as a epsilon. We are getting output as a epsilon. Now Q1 after accepting B, we are in the same state. Top of the stack is A and we are getting output as a epsilon. Okay. Now Q1 after accepting epsilon, we are in Q2 state. As it is not the final state accepted by empty stack, that's why it is not shown by the double circle. Top of the stack is Z0 and output will be epsilon. So this is the transition diagram. Same transition diagram here we have shown. Okay. Now design through the final state. So what is the change? Here epsilon and z0, and that will be shown by using double circle. Remaining will be as it is. So in this way we can design the PDA for the given problem statement. I'll stop here. Thank you.